Hey everyone, welcome back to my YouTube channel part 1. The Hook, the cosmic mystery. What if everything you thought you knew about our solar system was wrong? What if the celestial neighborhood we call home, the one with 8 familiar planets orbiting our sun, is actually incomplete? Imagine a time, billions of years ago, when our solar system wasn't quite what it is today. Time when there might have been more worlds, more massive planets, performing a cosmic ballet that ended not in harmony, but in violent ejection or even destruction. You're talking about lost worlds. Not just theoretical possibilities, but planets that scientists now believe once existed, leaving behind only their gravitational echoes and the profound mystery of their absence. This isn't science fiction. This is the cutting edge of planetary science, a detective story unfolding across billions of years and billions of miles. We are searching for ghosts in the cosmic machine, for the specters of planets that shaped our solar system, perhaps even making Earth's existence possible, only to vanish without a trace. The evidence is subtle, hidden in the tilt of distant giants, in the scars on our moon, and in the peculiar orbits of icy bodies far beyond Neptune. It's a tale of colossal violence, of planetary migration on a scale almost impossible to comprehend, and of a solar system that constantly reinvents itself. The implications are mind-bending. If planets can simply disappear, hurled into the cold, dark embrace of interstellar space, what does that say about the stability of our own world? What does it tell us about the commonality of life in the universe, if entire ecosystems could be snuffed out in a gravitational slingshot? This journey will challenge your perception of our cosmic backyard, revealing a hidden history that is both terrifying and awe-inspiring. It will uncover the clues, follow the scientific breadcrumbs, and piece together the incredible story of our solar system's tumultuous youth. But to understand this cosmic mystery, we need to go back to where it all began, to the violent, formative years of our cosmic home. Part 2, the discovery story. For centuries, our view of the solar system was largely static. Planets formed, settled into their orbits, and stayed put. It was a comforting, orderly picture. But in the late 20th and early 21st centuries, astronomers began to notice anomalies, subtle hints that this serene image was far from accurate. The story truly began to unravel with the puzzle of the outer solar system, specifically the Kuiper belt, a vast ring of icy objects beyond Neptune. Scientists observed that the Kuiper belt had a surprisingly sharp outer edge. Why would it just cut off? It was like finding a perfectly mowed lawn in the middle of a wild forest. This observation, among others, began to suggest that something powerful had sculpted this region, something that couldn't be explained by the planets in their current positions. Then came the models. Computational power grew exponentially, allowing scientists to simulate the early solar system with unprecedented detail. And what they found was shocking. The initial simulations, trying to explain the current architecture of our solar system, the positions of the gas giants, the distribution of the asteroid belt, simply didn't work if the planets started out where they are today. There was a profound disconnect. The orbits of the gas giants, Jupiter, Saturn, Uranus, and Neptune, were unstable in these early models. Something had to have happened to settle them into their current, stable configurations. This tension built for years. Astronomers like Alessandro Morbidelli, Rodney Gomes, Hal Levison, and David Nesvorny were at the forefront of this intellectual battle. They wrestled with the data, running simulation after simulation, each one yielding more questions than answers. It was a period of intense frustration, of conflicting data points that refused to align with existing theories. The conventional wisdom was crumbling, piece by agonizing piece. They needed a new paradigm, a revolutionary idea that could reconcile the chaos of the early solar system with the order we see today. But then something unexpected happened. A breakthrough emerged from their collective efforts, a model that would shake the foundations of planetary science. The NICE model, named after the city in France where much of the work was done. This model proposed that the giant planets didn't form in their current positions. Instead, they formed much closer together, in a compact configuration. Then, through gravitational interactions with the vast disk of planetesimals that surrounded them, they began to migrate. Jupiter moved slightly inward, while Saturn, Uranus, and Neptune moved outward. This wasn't a gentle drift. It was a slow, inexorable march that built up to a climactic, chaotic event. This period of intense gravitational upheaval, according to the NICE model, was the key to explaining many of the solar system's mysteries. It was a truly profound shift in understanding, revealing a dynamic, violent past that had been hidden in plain sight. Part 3. The investigation deepens. The NICE model provided a framework, but the devil, as always, was in the details. The investigation deepened into an unfolding detective story, with each piece of evidence acting as a clue to a grander, more violent past. Let's look at the evidence, layer by layer, building a picture of a solar system forged in fire and chaos. First, consider the late heavy bombardment. Our moon, Mars, and Mercury bear the scars of this cataclysmic event, a period roughly 4.1 to 3.8 billion years ago, when the inner solar system was pummeled by an intense barrage of asteroids and comets. For decades, scientists struggled to explain this sudden surge of impacts. Where did all that material come from? The NICE model offered a stunning answer. The planetary migration, particularly the outward movement of Saturn, Uranus, and Neptune, destabilized the Kuiper belt and the asteroid belt, flinging billions of icy and rocky bodies inward, straight into the paths of the inner planets. It was a cosmic shooting gallery, and Earth, along with its neighbors, was caught in the crossfire. This wasn't just a theory, it was a direct consequence of the giant planets shifting their cosmic dance. But here's where it gets even weirder. The NICE model, in its original formulation, had a problem. While it explained the late heavy bombardment and the current orbits of the outer planets, it struggled to explain the precise architecture of the asteroid belt and, crucially, the relatively low mass of Mars. This led to a refinement, a plot twist in our scientific understanding, the grand hack hypothesis. Imagine Jupiter, the king of planets, not just migrating outward, but first taking a dramatic detour inward, almost to the orbit of Mars, before being tacked back outward by its gravitational interactions with Saturn. This grand tack would have swept through the early asteroid belt, scattering and clearing out much of its material, explaining its current sparse nature. It would also have pushed a lot of material towards the inner solar system, influencing the growth of Mars. This was a revelation, showing that planetary migration wasn't just a one-way street, it was a complex, multi-directional journey. Now, let's talk about the missing piece. The models, especially those attempting to perfectly replicate the current solar system, often required a bit of extra gravitational oomph. They needed something more to kick Neptune and Uranus into their wide, eccentric orbits and to scatter the initial disk of planetesimals efficiently. This led to a truly astounding hypothesis. What if there was a fifth giant planet? Not a dwarf planet like Pluto, but a full-fledged gas giant, perhaps similar in size to Uranus or Neptune, that once existed in our solar system. Imagine the scene. 4 gas giants, plus this fifth, unknown sibling, all locked in a gravitational embrace. As they interacted with the primordial disk of icy bodies, their orbits slowly began to change. Cumulative effect of these interactions, like a cosmic game of billiards, would eventually lead to a moment of intense instability. One of the planets, perhaps this fifth giant, would receive a gravitational kick so powerful that it would be ejected from the solar system entirely, hurled into the cold, dark expanse of interstellar space, a rogue planet forever wandering the galaxy. This ejection event, while devastating for the lost world, would have provided the necessary gravitational impulse to settle the remaining 4 giants into their current, stable orbits, simultaneously explaining the Kuiper belt's structure and the late heavy bombardment. The evidence for this ejected planet is indirect, but compelling. The very dynamics that explain the outer solar system's structure often work better with an extra player in the early game. It's like trying to solve a puzzle with one piece missing, knowing that the missing piece is essential for the picture to make sense. This wasn't just a theory to explain away a problem. It was a consequence of the physics, a natural outcome of such a violent and dynamic past. Wait for it. The very stability of our solar system, the reason Earth exists as it does, might be built on the destruction or ejection of another world. Part 4. The modern quest, our understanding of these lost worlds, has been profoundly reshaped by cutting-edge technology and advanced computational power. Supercomputers, capable of running billions of gravitational interactions over cosmic timescales, have allowed scientists to refine the NICE model and the grand tack hypothesis, testing countless scenarios to see which best matches the solar system we observe today. These simulations are incredibly complex, painting a dynamic picture of our solar system's youth that was unimaginable just a few decades ago. Furthermore, observations of exoplanetary systems have provided crucial context. You're now discovering thousands of planets orbiting other stars, and what we're finding is a universe teeming with planetary migration and violent interactions. Many exoplanet systems feature hot Jupiters, gas giants orbiting incredibly close to their stars, which are believed to have migrated inward from much farther out. We also see systems with highly eccentric orbits, or planets that appear to be missing, hinting at past ejections. These observations provide external validation for the idea that our solar system's chaotic past, including the potential for lost worlds, is not unique, but rather a common feature of planetary formation across the cosmos. But the quest for lost worlds isn't just about ancient history. It's an active hunt, right now, for a potentially still existing lost world in our own solar system. The Planet 9 hypothesis is a perfect example of this modern quest. Beyond Neptune, in the frigid reaches of the outer solar system, astronomers have observed a peculiar clustering of orbits among several distant trans-Neptunian objects, or TNOs. These icy bodies, instead of orbiting randomly, appear to be shepherded by the gravitational influence of something massive, something unseen. The most compelling explanation for this observed clustering is the presence of a distant, super-Earth or mini-Neptune-sized planet, roughly 5 to 10 times the mass of Earth, orbiting far beyond Pluto. Search for Planet 9 is a monumental undertaking, requiring vast sky surveys and powerful telescopes. While not a lost world in the sense of being ejected, if confirmed, it would be a hidden world, a relic of the early solar system that simply settled into an incredibly distant, eccentric orbit. It represents the ongoing struggle to complete our census of the solar system, to understand if there are indeed more massive bodies lurking in the shadows. Telescopes like the Subaru telescope and future observatories like the Vera C. Rubin Observatory are designed to scour the skies for such faint, distant objects, pushing the boundaries of what we can see and challenging our understanding of our cosmic backyard. The scientific battle rages on. Some theories suggest that the observed clustering of TNOs could be explained by the cumulative gravity of many smaller, unseen objects, rather than a single large planet. Others propose that the solar system's birth environment, embedded within a cluster of young stars, could have gravitationally influenced the outer solar system in ways we don't yet fully understand. But the most recent discoveries continue to lean towards the existence of a massive, distant perturber. The sheer scale of this detective work, using light from billions of years ago and the faintest whispers of gravity, makes you feel like you're right there, peering into the abyss with the astronomers. The possibility of finding Planet 9, a true lost world hiding in plain sight, represents a climactic revelation that could forever change our solar system map. Part 5. The implications and future the existence of lost worlds, whether ejected from our solar system or simply hidden in its farthest reaches, profoundly reshapes our understanding of planetary formation and evolution. It tells us that the universe is a far more dynamic and violent place than we once imagined. Our solar system, rather than being a serene, stable system from its inception, was forged in a crucible of gravitational chaos. This isn't just about a missing planet. It's about understanding the very fabric of cosmic existence and our place within it. What does this mean for humanity? It means our existence on Earth might be a direct consequence of this cosmic billiard game. The ejection of a fifth giant planet, for example, could have been the very event that stabilized the orbits of the remaining planets, creating the conditions necessary for life to emerge and thrive on our world. It highlights the incredible fragility and interconnectedness of planetary systems. If a world can be hurled into interstellar space, what does that say about the long-term stability of any planetary system? Could Earth itself one day face such a fate, perhaps in the distant future during a galactic encounter? This understanding also broadens our perspective on the search for life beyond Earth. If planetary ejection is a common phenomenon, then rogue planets, stripped of their stars and wandering the galaxy alone, might be far more numerous than previously thought. These rogue worlds, perhaps warmed by internal geothermal heat, harbor subsurface oceans and even life. The idea of life thriving on a planet without a star is a mind-bending concept, born directly from our investigation into lost worlds within our own solar system. The future of this quest is incredibly exciting. The Vera C. Rubin Observatory, with its unprecedented wide-field surveys, is expected to revolutionize our ability to detect faint, distant objects in the outer solar system, significantly boosting the chances of finding Planet 9. Future missions, perhaps even dedicated probes to the outer solar system, could provide direct observations of these distant realms, offering definitive answers to whether these gravitational whispers are indeed the echoes of a lost world. This isn't just about finding another dot in the sky. It's about completing the story of our cosmic home, understanding its tumultuous past, and gaining profound insights into the destiny of planets across the universe. Part 6. The profound conclusion. We began this journey by asking if our solar system was incomplete, if there were ghosts in the cosmic machine. And the answer, through billions of years of cosmic history and cutting-edge scientific detective work, is a resounding yes. Our solar system is indeed a place shaped by lost worlds, by planets that either vanished into the interstellar void or remain hidden in its deepest shadows. We have followed the clues. The scars of the late heavy bombardment, the peculiar architecture of the Kuiper belt, the migration of the gas giants, and the tantalizing gravitational whispers of a potential Planet 9. The profound implication is that the universe is a dynamic, violent place of constant creation and destruction. Our serene solar system, the one we gaze upon today, is a survivor, a testament to a chaotic past where worlds were born, migrated, and sometimes were utterly lost. Our very existence might be a direct consequence of this planetary upheaval, built upon the demise or ejection of another world. This investigation doesn't just fill in a missing piece of the cosmic puzzle. It fundamentally alters the picture itself. It leaves us with new questions, questions that stretch the imagination to its limits. How many other lost worlds are there in our galaxy? What secrets do they hold, drifting silently through the cosmic dark? And what does it mean for us, knowing that the stable ground beneath our feet is built upon such a tumultuous and violent past? The universe is a graveyard and a nursery simultaneously, and we are living in a solar system shaped by colossal violence, by worlds that vanished, leaving only their gravitational echoes and the enduring mystery of their absence. Thanks for watching. Subscribe to my YouTube channel.